Okay, in this video we're going to talk about the free response question number 2 from the 2011 AP Calculus AB Form B examination. So our problem here says that we have a 12,000 liter tank of water filled to capacity. At time t equals 0, water begins to drain out of the tank at a rate modeled by R of t. Measured in liters per hour, where R is given by the piecewise defined function seen below. And then we have 4 questions about that. First, is R continuous at t equals 5? Then find the average rate at which the water is draining from the tank. Then find R prime of 3, and then set up an equation to find the time when the amount of water in the tank is 9,000 liters. So let's go through this one by one. Let's move this up out of the way here. All right. So the first question is R continuous at t equals 5. So what we need to say is that, first of all, both parts are continuous. So we just need to know is the value at 5 equal for the 2 parts. So we just plug in 5, and you get 600 t over t plus 3. When we plug in 5, we'll get, so then we get 600 times 5 over 8, which is 375. And then for the second part of my piecewise function, we have 1,000 e to the negative 0.2 times 5, which, since this is a calculator allowed question, the first 2 questions on the 2011 exam are calculator questions. Just going to plug that into my calculator, and we get an approximate answer of 367.879. And those aren't the same, so my answer would be no, R is not continuous at 5. There is a jump. Because there is a jump. We jump from 375 when we're approaching on the left side, and then all of a sudden we're at 367 from the right. So it's not continuous. We could, if you wanted to, check the limits for each of these things, but because each piece of my piecewise function is a continuous rational function or exponential function, I know that those pieces individually are continuous, so you just have to check what happens at 5 for each of the 2 functions. Okay, so that's part A. Pretty straightforward. Let's move that off to the side in case we need it later. And let's talk about B. So we need the average rate at which water is draining from the tank. So for part B, what we're going to do, average value, hopefully you remember, average value of a function from a to b is 1 over b minus a times the integral from a to b of your function f of x dx. So I just need to do that here. The one part that makes this a little bit tricky when you think about it is that it's a piecewise function, and so immediately you might think, uh-oh, that's going to change things, but it doesn't. I still just need to take 1 over we'll start with 8 minus 0, times the integral from 0 to 8 of r of t dt. And again, you might think that things are going to be different and weird here because it's piecewise, but nothing changes. You just deal with the two pieces separately. So I will get 1 over 8 times, first of all, the integral from 0 to 5, the first piece, of 600 t over t plus 3 dt, and then add that to the second part, which is the integral from 5 to 8 of 1,000 e to the negative 0.2 t dt. And again, this is a calculator allowed question, so you can just plug that all in your calculator, and you get an average value of 258.052. And so that's the average rate. And so we could put liters per hour there if we wanted to. They don't say we need units on this one, so not a big deal. Sometimes they are specific and say you do have to have units. But that's the average value. We should know that formula for average value, and the fact that it's piecewise doesn't actually change anything. You just need to take the integral of the two pieces separately. That's all. So that's part B. So again, done with that. Let's get that out of the way. Save it for later in case we need to look at it again. Now C says find r prime of 3, and then using correct units explain the meaning of what the value of that value in the context of this problem. So r prime of 3, well, since I'm looking for r prime of 3, I know that I only have to worry about the first of the pieces because 3 is between 0 and 5. It's not greater than 5, so I'm only worried about the 600t over t plus 3. So I'm just going to take the derivative of that first part. So we'll have to use quotient rule. So low t plus 3 d high times 600 minus high 600t d low, which is just 1, and then square the bottom, and away we go. If you're not familiar with that little song for the quotient rule, then I'm sorry. You should be familiar with it. It's a good song. And so that's the derivative of the first part of r, the first piece from 0 to 5. And now I want to know the value of the derivative at 3, so I just plug in 3 for t. And when I do that, I will get 6 times 600 minus 600 times 3, and then the times 1. I'm not going to write that again because I don't need it. Then on the bottom, 3 plus 3 is 6, squared is 36. And when we simplify that, we get 50. And because this was already a rate of, this was already a rate of change, liters per hour, and then I took the derivative of that, it's almost like an acceleration, because velocity is the rate of change that we work with the most, and then when you take the derivative of that, you get acceleration. So if my original function was in liters per hour, then this is going to be in liters per hour squared. Just like acceleration is in meters per second squared if your velocity was in meters per second. So this is going to be 50 liters per hour squared. And to explain that, because it says explain the meaning of that value in the context of this problem, and so we could say the acceleration of the drainage is 50 liters per hour squared, or we could say the drainage rate is increasing at 50 liters per hour squared at time equals 3. And that's what that 50 means. Alright, so that was part C. Let's label that too. And now, let's move that out of the way and make some room for part D. So part D says write but do not solve an equation involving an integral to find the time A when the amount of water in the tank is 9,000 liters. So what we have to think about here is they've given me a rate equation to start, and now they're asking me about the amount of water that's in the tank. So immediately I should think about going from a rate to an amount. I'm thinking about integration here. And if I want the total amount to be 9,000, I need to take the amount that I started with and then subtract the amount that's drained out. So for part D, I start with my 12,000, and then I subtract the amount that drained out. Now, what's the amount that drained out? Well, it's the integral of the rate that it's draining. And the question is, well, how long should it be draining? But that's literally the question. We want to know how long it takes this, so from 0 to A, to get to a value of 9,000. That's what I want. I want my initial value, 12,000, minus the amount that drained out, this integral from 0 to A, to equal 9,000. And we really could solve this for A if we wanted to, but they tell us don't, so we won't. And that's number 2 on the 2011 Form B AP Calculus AB exam.